Hello everyone, welcome to the solution of LeetCode problem 886 named Possible Bipartition. In this problem, we want to split a group of n people level from 1 to n into two groups of any size. Each person may dislike some other people and they should not go into the same group. Now, we are given an integer n and the array dislikes. Here, dislikes of I is equal to A of I and B of I indicates that the person labeled A of I does not like the person labeled B of I. Now, we have to return true if it is possible to split everyone into two groups. Otherwise, we have to return false. This is the plain and simple problem statement. I hope you understand it. I will explain the example in the algorithm section. Here, to understand the algorithm, we have taken this example. Here, the number of people is 4 and the dislikes value are 1, 2, 1, 3, 2, 4. So 1, 2 is connected, 1, 3 is connected, 2, 4 is connected. Now, we have to separate each of the person into two groups, or we have to make two groups such that no person that dislike each other will exist in the same group. So here, it is possible that we will make group 1 with 1 and 4 and we will make group 2 with 2 and 3. So here, this is a basically graph coloring problem or graph bipartition algorithm. That means what is the basically graph coloring problem is, suppose this is our starting node and we have made it color red. Now, as we have made the color red, so we have to make the alternating color of its two neighbor. So let's make the color 2 and 3 will be green. As we have made 2 and 3 green, so we have to make the color 4 alternating. So we have to make the color 4 red. So here in the red group, 1 and 4 exist, and in the green group, 2 and 3 exist. And here, 1 is connected to 2, 1 is connected to 3, and 2 is connected to 4. So here we have seen that we have separated them into two groups, 1 and 4 and 2 and 3, such that there is no connection between 2 and 3 and 1 and 4. That means all of the nodes in the same group does not hate each other, but each node in the first group hate another node in the second group and vice versa. So here, this is the basic graph coloring problem. So now let's see how can we solve this problem. To solve this problem, we have taken a color array and a visited array. Now initially, we are at this root node 1. So let's make the visited 1 true and make the color of 1 will be 1. Now we have to go to the left subtree and we have to go to the right subtree. Now in the left subtree, as the color of 1 will be 1, so we have to make the alternating color which is 2 for both of his children. So we have to make the color 2 for the 2 and 2 for the 3 and make them visited. Now from the node 2 we can go to the 4 and make the color 1 and make it visited. So here for this color 1, this color 2 will be 3 minus its parent color, which is 3 minus 1, 2. This color 1 will be 3 minus 2, its parent color, which is 1. So basically, This is how the graph bipartition algorithm works, and we have made alternating color. This level has the red color, this level has the red color, and this second level has the green color. So this is how basically the graph bipartition works. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named possible bipartition, which is integer n and vector of a. Now we are taking an adjacency list, color and visited array. Now we are making the adjacency list here. And for each of the node, if current node is not visited, we have to call a DFS function with the current node with the color 1. Now inside the DFS function, we have to mark the node visited and store the node color, which is color, and we have to iterate each of the children in the node's adjacency list. And if the current children is not visited, and here, if after recursively calling the DFS function with the alternative color, which is 3 minus color to the children, if it is returning true, we have to return true. That means it is not possible for us to make the graph bipartite. Here is the base condition, which is if the color of node is equal to color of children. If it is, that means it is not possible for us to make the graph bipartite. Because for a graph to be bipartite, the color of children should be alternative to the color of parent. After that, if for each of the neighbors it did not return true, we have to return false. That means this graph is possibly a bipartite. Finally, if the DFS function returns true, that means it is not possible for us to become the bipartite. So we have to return false, otherwise we have to return true. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.